This video is for my pre-algebra classes. It's over lesson 37, areas of combined polygons. Well, ladies and gentlemen, in order to find the areas of combined polygons, if you can find the areas of their individual pieces and then just add them together, then you'll have the area of the whole polygon. So it's important to know the formulas for the individual pieces. So in this lesson, we have a few that we're going to review. So first up, if you grab your yellow highlighter, let's highlight this one here. The area of a triangle is A equals 1/2 BH. A equals 1/2 BH, which of course means area equals 1/2 times base times height. Now a couple things to keep in mind here. When we say B is the base, it is important to remember that the base is one of the sides. The base is always going to be one of the sides of your triangle. Now, common error here is students tend to think that B means bottom, and so they assume that it's the bottom side of the triangle, and that is not correct. It does not have to be the bottom side of the triangle. The reality is you can always take a figure and rotate it, and what was the bottom now will be a vertical side. Or I can rotate it again, and what used to be the bottom now is on top. And so because of this, you cannot think of base meaning bottom. Base is one of the sides. Now, it's not just any side though, because it also pairs up with H, the height. And the height can be a side, but it doesn't have to be a side of your triangle. But what it does have to do is it does have to make a right angle with the base. Makes a right angle with the base. So it will go from the base to the opposite vertex, making a right angle with the base. Okay, and we'll see that a little bit more in just a second. All right, for our next formula, here we have the area of a rectangle. So area of a rectangle, A equals LW. Area equals length times width. Now I'm going to put a little correction in here because if you look at this L, this lowercase l in print, I disagree with how our book chose to print this out. This to me is an error. You will often see in mathematics that a cursive L will be used for that length so that it does not get confused with the number 1. It makes it very clear. Now you could say, why don't we just use a capital L? But remember that there is this tendency within formulas that things that we calculate, like area, perimeter, volume, that these are given capital letters, but that things that we could measure, that you could actually take a ruler to in real life and measure, like length, width, base, height, those are usually lowercase. So our uppercase and lowercase in formulas actually do communicate something. And so we're going to keep it lowercase, we're just going to make it cursive. This is the only time in my class I require cursive. So go ahead and change those two L's there to cursive L's. And so we have length and we have width. So in the example here, they want you to find the area of figure A, B, C, D, E, F. And so remember, when we've got these polygons, we basically name them by tracing. So if you were to go around this figure here, moving around the figure, we've got A to B to C to D to E to F to A. I actually would disagree with this name here. Since they're using 6 letters, it would make it look like this is a hexagon. But if we take a look here, we've got 1, 2, 3, 4, 5 sides. So there really should only be 5 letters in the name. So I'd like you to go ahead and put an X on that. That name is incorrect. A proper name for this would be A, B, C, E, F. So D just happens to be a point on this side CE or EC. So we wouldn't break this up into two sides. So D really actually shouldn't be in the name. Now it's going to be important for finding the area potentially, but it really shouldn't be in the name. So we got this figure here, and we know that it's 6 feet across there. We know it's 10 feet there, 6 feet, and 6 feet. And so they chose to draw segment FB across there to form square FBCE. So F to B to C to E. And that is a square because we know this is 6 feet and that's 6 feet. We know this is 6 feet, and since these are rectangles here, that must be 6 feet as well. So they chose to label point G, which is the intersection of segments FB and AD. So FB and AD intersect there at G. Now they want us to calculate the area of FBCE. So here's what I'd like you to do here. I'd like you to please take your highlighter and your yellow highlighter. We're going to highlight this formula right here, and then above it we're going to write square. Now squares are rectangles, so you could technically just reuse the formula for rectangle to find the area of a square. However, since a square is a special rectangle, though, it does get its own special formula, which we see being used here. So the area of the square is S squared. So S, the side length, is 6 feet. Notice that they used parentheses here because parentheses are going to make sure that the square applies to the entire side. So the side is not just 6, the side is not just feet, the side is 6 feet. The side is 6 feet. However, we need the parentheses to make sure the square goes the whole thing. So 6 feet times 6 feet becomes 36 square feet. Then they found AG. Now notice there's no segment symbol above this. With no segment symbol, this means we're talking about the length. So what is the length of segment AG? Well, since the length of segment AD is 10 feet, and the length of segment GD is 6 feet, and we know that that's 6 feet there because this is 6 feet and that's 6 feet, and well, rectangles, opposite sides are the same length. And so therefore AG must be 4 feet, because the 10 feet minus the 6 feet must be the 4 feet. Then we calculated the area of triangle AFB. So A to F to B, there's my triangle. A to F to B, then back to A. So triangle, remember, is A equals 1/2 BH. So it equals 1/2, that says 1/2, so 1/2 times the base is 6 feet across there, times the 4 feet that we figured out was AG, that's my height. And so you can do this in any order you want as long as you do all of it. So I could find half of 6, then multiply that by 4. I could find half of 4 and then multiply that by 6. Or we could find 6 times 4 and then take half of it. Any way you do it, though, you're going to get 12 square feet. So to find the total area of, and we'll just cross the D off this time, ABCEF, well, the area of ABCEF is equal to the area of the square plus the area of the triangle. So the 36 square feet plus the 12 square feet makes a total of 48 square feet. Now, I'm not going to make you write out 5 steps like this. We're going to look at some practice problems now to see how to show our work for this, and it's going to be a bit smaller, good bit smaller. So for this first figure here, what we're going to do is we're going to kind of do like they did up here, and we're going to cut it up into two pieces where we know how to find their areas. So when I look at this, what stands out to me is I've got this nice, almost rectangular looking shape right there. So I'm going to go ahead and, on my homework, go ahead and actually copy that on the homework. And then once it's copied on the homework, I'm just going to draw on this, and I'm going to draw it in dashed just so that way when I'm doing this on the homework, I can see that that was not originally something that was written in. And so now I've got this rectangle here. And I know if that's 6 inches, then across from it must be 6 inches. If that's 3 inches, then across from that must be the 3 inches as well. Opposite sides have the same length. Well, guys, if this is 3 inches, but the whole thing is 6 inches, then in this triangle, this must be 3 inches. So now that I've thought that through, let's go ahead and put this together. So I want to find the area. So I'm going to start with capital A. And then the rectangle is length times width. Length times width there. So here's what we do, what we're going to do for right now. I'd like you to take your orange highlighter and let's just highlight that in orange. So that's what we're looking at right now. So A equals length times width for a rectangle. So the length here is 6 inches, not just 6, but 6 inches, times the width is 3 inches. And then I want you to take that orange highlighter and just underline it. That is that orange portion. But now we need to add on the area of the triangle. So grab a new color, doesn't matter what you choose. I happen to grab my green. Something other than orange and yellow though. And so now I'm going to take a look at this triangle. So for this triangle, we know triangle A equals 1/2. We always start with a 1/2 times base. Now, since this 6 inches here and this 3 inches there make a right angle, you could use either one of these sides as your base, and the other will be the height. So I'm going to use the 6 inches here for my base, times a height of 3 inches then. And then since I did that in green, I'm going to highlight all of that in green. So there's my rectangle plus my triangle. If I just simplify this now, I should find the answer. I'm going to come down, I'm going to put a new equal sign underneath an old one because it's kind of going pretty far over. 6 times 3 is 18, so that's 18 square inches. Make sure inches times inches become square inches. Now over here, we got 6 times 3 again, but then we're going to take half of it. So half of 18 is 9 square inches. Add those together, 18 plus 9 is 27 square inches. The combined area is 27 square inches. All right, let's take a look at the next figure here. So the next figure, number 2, they've broken it up into a bunch of pieces. So we've got this rectangle in the middle that's pretty easy to identify. Then we've got these two triangles on these ends. Notice that they're both 1 meter there on the bottom, and then since they connect up with the rectangle, they're both 2 meters going up. So these two triangles are identical. That's going to be useful here in just a second. We're going to use that. Up top, we could treat this as 2 triangles, or we could treat this as one big combined triangle. So I would rather do that just for simplicity's sake. So I'm going to grab, we're starting over a new figure, I'm going to grab my orange again. And probably the easiest thing to start with is the rectangle. And so I'm going to start my A equals with that length times that width. So the length of 3 meters times the width of 2 meters. So that right there is the orange portion. All right. So next up, let's take this top part all together. So I'm going to treat this top part as one big triangle. So in this case, I've got this 3 meters, which we can see makes a right angle with this side of the triangle. So this side of the triangle is, well, if that's 3 meters on the bottom of that rectangle, it's 3 meters on the top of the rectangle. So the base is 3 meters. So 1/2 times 3 meters for the base times, well, 3 meters for the height. So that's my green portion right there. All right, I'm going to choose another highlighter. Doesn't matter what color you choose. I'm going to grab my blue. And I know, as we talked about earlier, that these two on the sides are identical. So since they're identical, what I'm going to do here in my work is, since there are two of them, I'm going to write a 2 first. And then I'm going to start it in the formula. So my formula for those guys will come after that. So 2 times is a triangle, so it's always going to start with 1/2. Times base, we can make 1 meter the base, times 2 meters is the height. So when you have identical pieces, you can put a number out front of the formula to say how many of those you have. All right, so now if we put this together, I'm going to go ahead and multiply. So 3 times 2 is 6, so we got 6 square meters. And then next, half of 3 and then times 3, that doesn't sound the easiest. So I might actually start with 3 times 3 here and then just cut that in half. And I'm going to put that as a decimal. So 3 times 3 is 9, and then half of that is 4.5. Half of 9 is 4.5. So 4.5 meters, square meters. And then finally, the last piece here, I'm going to take advantage of the fact that 2 times a half, if you double a half, you got 1. So this becomes 1 times 1 times 2. So that would be 2 square meters. All right, so if we add this up together, I've got a 6 plus a 4 is 10, plus 2 is 12, and then we got a 0.5. So 12.5 square meters. Now with this one, it's a little risky, but if these two sides actually do form just one big long side, we could have potentially treated this all as one giant triangle. And you've got to be careful about that because there are going to be times where the two sides will combine together to make one big side and times that they don't. But this time actually they do. So I'm using a concept called slope, which we really haven't talked about yet, that allows me to know that, yeah, they do match up. So if I treat this all as one big giant triangle, a different way to show our work for this guy actually would have been, instead of taking the pieces, putting the pieces all together as one big triangle. So a equals 1/2 times the base then would have been 1 plus 3 plus 1. So 5 square meters, or excuse me, it's 5 meters. And then for the height, well, you're going up 2 meters because of the rectangle, and then another 3, so 2 plus 3 is another 5 meters. And so that would have been actually the whole thing all together. Well, 5 times 5 is 25, and then if we cut that in half, hey, look at that. Again, we got 12.5 square meters. So there were actually 2 ways to do this one. All right, number 3. For number 3, again, I see 2 triangles, I see 2 rectangles. So first of all, when I look at the triangles, I see that this is 2 here, 2 yards here, 1 yard there, and then this must be 1 yard there. So my 2 triangles are identical again. My 2 rectangles as well are identical, but not only are they identical, if you take a look at your 2 rectangles, you could actually just put them together. And if we do put them together, then it's 2 yards this way and it's 2 yards that way. The 2 rectangles actually make a square. And that's where I'm going to start in my formula this time. So A equals S squared for a square. So the side length here is 2 yards squared. And remember that when we use exponents in our formulas like this, we do need to use parentheses around our measures. So that right there is the orange portion. Now, remember we talked about at the beginning the fact that these 2 triangles are identical. So just as we did in the last example, I'm going to write down that we have 2 of them, and then I'm going to use the formula. So since they're triangles, it'll always start with 1/2 times base. We could make 2 yards the base, and then the height is 1 yard. And now we simplify. So 2 yards squared gives me 4 square yards. And then down here, 2 times 1/2 becomes 1. So this is really 1 times 2 times 1 is 2 square yards. Well, 2 yards plus, first give me 4 square yards plus 2 square yards is 6 square yards. All right, ladies and gentlemen, and for our last one here, we're going to do something different. Now, we could again take this triangle here, we could cut this off and make another triangle, so we'd have a rectangle and 2 triangles, but I actually want to approach this one a bit differently. So instead this time, instead of thinking about putting things together, and so taking an area of a triangle plus the area of a, or excuse me, area of a rectangle plus the area of a triangle, or the area of 2 triangles plus the area of the square in between them, this time I'm going to think about it as something being cut away. This looks like a rectangle that's had a triangle cut out of it. So if we imagine this as one whole rectangle now. So area equals length times width. So the length here is 6 centimeters times the width is 7 centimeters. Now, in order to get this figure, though, I have to cut out, you know what, pink sounds like a good cutout color. It's the closest thing I have to red. If we cut out this triangle here, so subtract it, we'll have the area of the figure. So for triangles, triangles always start with 1/2 times, well, base, well, if the bottom of this rectangle is 6 centimeters, then the top of it would also be 6 centimeters. And that would be, could be the base for my triangle. And then finally over here, if the whole side is 7 centimeters, and this is 3 centimeters, then this must be 4 centimeters. So the height of this is 4 centimeters. And so that's the piece that I'm cutting out. So 6 times 7 is 42, so we have 42 square centimeters. Whoops, forgot the 2. I'm going to have to erase that, make it right. 42 square centimeters, there we go. Minus, now over here, I might do half of 6 is 3, times 4 is 12, so minus 12 square centimeters. I ran out of room, so I'm going to line up a new equal sign with an old one. I'm just going to have to drop below those words since they're in the way. And 42 minus 12 is 30 square centimeters. And that, ladies and gentlemen, is the end of our lesson.